So what does it look like it's doing? Can't use the word to define it.
Sliding.
Sliding, right? Slide, slide, slide. Cha-cha slide all the way down until it turns into Spanish down here. Alright, so a big thing about translations is there's two letters in here, this SL right here that reminds you that it is a slide. You guys are going to be good at sliding things, right? When you slide your phone across the desk, does it change sizes? Does it slide from Apple to Android? No, so a translation is what we call in geometry a rigid transformation. So what do you think rigid means?
Hard.
If I slide this from here to here, did anything change?
No.
Did it change shape?
No.
Did it change sizes?
No.
Did it change brands?
No.
Did it change carriers?
No.
So a rigid transformation is a congruent transformation. Whatever I start with, I will end with the exact same thing. It's a rigid transformation. Same size, same shape. That congruence word, right? Congruence. The biggest issue for us today is going to be the notation. Like when you see the instructions, do you understand what it means? That is going to be the biggest issue. The other big issue is going to be slowly counting things correctly. So a lot of different ways to do this. You find the best way and we'll work with it together. So a translation is a transformation that maps all points of a figure the same, or it maps all of, a transformation that maps all points of a figure the same direction in the same distance. I might have those back, the same distance in the same direction. It has the same distance in the same direction. So let's say I pick this shape. What shape is that?
Rectangle.
Nope. It's a quadrilateral. There's no information to support anything, but it's a quadrilateral. Let's say I pick one vertex, like this one right here, and I slide it that way. Okay, how are we going to talk about what that way is in math today? Which direction did this go?
Right.
It went right.
Diagonally right.
It went to the right this way, didn't it? And what else did it do?
Down.
And it went down. So if this vertex goes to the right and down, what does every other vertex have to do? Let's say it went right 4 and down 2. How is this one going to slide? It's going to go right 4 and down 2. What about this one?
Right 4 down.
What about this one?
Right 4 down.
So no matter what happens, I will get the same shape. It's a rigid transformation. Every vertex will move right 4 and down 2. So that's a rigid transformation. Let's say I start with a triangle. Okay? Which way did that triangle move?
Right. Left. Both ways.
You don't know. Why do you not know which direction it moved?
Because there's no arrows pointing in a direction.
Okay, so generally we have shapes. Let's call this triangle big. Okay, so this triangle would also be. Does that help me figure out which way that triangle's sliding?
No.
No. So what else can we do?
Throw arrows.
No. Now what?
No.
Which way did the triangle move?
To the left.
It moves left. Right? You see how it's just B-I-G? This is pronounced B prime, I prime, G prime. That means that it has been transformed. Homeboy, Optimus Prime. What is he? Thank you. Somebody. A
Prime.
transformer, Optimus Prime. So anytime you start from your truck, you transform and become the robot. That's why it's B prime. He has been transformed. Does that kind of make sense? Anytime you see this called prime notation, it lets you know how many times it has been translated or transformed. So, what do you call that?
Transform 3 times.
That's I triple prime, or B triple prime, I triple prime, G triple prime. How many times has this BIG triangle been transformed?
3 times.
3 times. Do we know how it's been transformed?
No. Left 3 times.
We don't know. We just know that it's been moved 3 different times. And then it went up, it got reflected, then it moved again. That's 3 different translations. So how do we write it? This is the part that's going to be difficult for us. Believe it or not, there is 3 different notations for translations. Which one do y'all want to see?
How to write it.
The easy one, the hard one, or the confusing one?
Confusing.
The confusing one.
And work backwards.
Here is the confusing one. I'll write this one once, probably the last time I ever write this. It's called a mapping notation. Right? Mapping notation. Mapping notation looks like this.
What?
You like that or not like that?
Add numbers? What?
So here's what it's telling me. That any point xy will map to x plus 2 comma y minus 3. This tells me that the x moves right 2 and the y moves down 3.
So the numbers can be anything.
Anything. So this is a general rule. So no matter what point I put down, I know it will start here and it should go right 2 and down 3.
Okay.
That's what it means, what mapping notation means. No matter what figure you draw, your pre-image should move right 2 and down 3 to create your image. That is a very textbook way of doing it. Right? This is called, you ready for this one?
Yes.
Vector notation. And your whole test is in vector notation. Vector notation. Ready for this one? So can you like unmath that in your head?
No.
So this gigantic T stands for translation.
Translation.
Translation. Now inside the vector it says 2, 3, 2, negative 3. That
Over
means
2.
go right 2 and
Down 3.
down 3. And we are doing this sort of transformation, this translation to what point? X. So this notation only moves point X. This moves every point we put down. And then you also see this one. Parentheses 2, 3. This is the lazy way. The lazy way. You just put coordinate 2, 3 down. It's just telling you 2, 3. So I think we're having an issue with like this right here. Why does this mean right 2 down 3? That makes sense to anybody? If I put a coordinate grid down and you start here, how do you plot the point 2, negative 3?
Over 2, down 3.
Whoa. Not sure what happened there.
Mapping notation.
Mapping negation.
Mapping notation.
Alright, let's just try it out. Alright, so it says, for a translation, you just move or slide without rotating or resizing. And the way to remember a translation is that translate means slide. The SL means slide. So, look at these two notations. Which one is the original figure, the OG? Which one's the new figure, the new guy?
The A prime, B prime.
Is this new or old?
New.
This is the new figure. This one is the old figure. So it makes a huge difference. If I'm going to do my vector notation, what is the transformation that I'm applying? Transformation is the big daddy, but what is the one specific dance move that I'm performing? Slide. And what letter do we do that for our vector notation? T for translate. So that big T tells me I'm about to slide or translate a figure. Now I need direction. I need how many dance moves am I doing? How did I get from here to here? So we do that singular directions. We always go left and right before we go up or down. So you get to pick any point you want.
B.
B. Now, if I start at B, where should I end up?
C.
No.
D.
No.
B.
B. If I start at B, I should wind up at B prime. And it's one transformation. So I need to count from here over and up to B. So how far did I go over?
1, 2, 3, 4, 5, 6, 7, 8, 9.
I went over 9. So did I go plus 9
Plus
or minus 9?
9.
Plus 9. Plus 4 or minus 4?
Plus 4.
So this says if I take my old shape and I move it right 9 and up 4, I will wind up with my new shape. Well, what point did I translate?
B.
B. Did I translate just B or did I do A, B, C, and D?
All.
All of them. So I need to say, I need to translate all 4 points. This math rule takes this shape and slides it over 9 and up 4. That is the extent of what I'm trying to get across to you guys today. Does that kind of make sense? What's the hardest part? Is anybody scared about how to create these two numbers?
No.
It could be iffy, right? We've only done it one way. Let's try another one. Okay, so we have a red shape and a green shape. This is the green shape over here. This is the red shape over here. Which one's the new shape? Which one's the old shape?
Green is new.
Green is the new shape. How do we know that green is the new shape?
It's X prime.
It's got the primes on it. This is the new shape, so this is the old shape. Now what they're telling you is that the rule that we applied was a translation with a magnitude of 5, negative 1. Which means I went how many to, what does that mean? What does this 5 mean right here? That means right 5. What does this negative 1 mean? Down 1. So they want me to take the coordinate for point W, go find point W, which is at, the draw, where's the origin? Where is the origin? Right below W right here? No, this is it right here. Anybody else have that problem besides me? So where is W? What is the coordinate location of W?
-4.
-4,
1.
1. So it's saying if I do -4 plus 5, you get 1. And if you do 1 minus 1, you get 0. And that should be the mathematical way to find a W prime. Is W prime at 1, 0? Yeah. Would anybody do that kind of math like that? What would you probably do? I would probably just count 1, 2, 3, 4, 5, and put a dot there. And I know that's where it is. Is see the difference in what I'm doing? Is anybody gonna math to find the new point, or is anybody count to find the new point? You're gonna count, so let's just kind of scrub that. That's an option. I'm not gonna do it. So here we go. Here's the lazy way. The lazy way says translate by -2, -3. I want us to write the rule, and I want us just to draw the new picture. So what is the rule? What is the vector notation for the rule? T.
Parentheses. Sideways V.
You remember what those are called?
And then it is -2, comma, -3. Then another sideways V.
And what are we translating?
1 point. Because you can't do it all by that.
I can do all of them. What shape am I translating?
A, B, C.
What's it called? Triangle. So I'm just going to say I'm about to remove this triangle. -2 and -3. So you have to do it from each vertex. So pick a vertex. I'm going to pick this one right here. I need to do -2, -3. So what does that mean?
Down 2, over 3.
That means left 2. It's like plotting points. You always go left and right before you go up or down. So here's a new point. What do I do to this one? What do I do to this one? And then always connect your points. You can use your ID. Cora, does it look like the orange triangle is exactly the same size as the black triangle?
Yes.
Yeah, it does. So if you can count today, can you be successful?
Yes.
Right? So remember, the first day is always the easiest day, right? We're just counting today. Guess what you got to do for reflections? Count. What about rotations?
Count.
No. Sorry. Rotations are the hardest one. So I'm going to save that for Monday next week. All right, let's try this one. It says translate by the rule -1, 3. I want you guys to write the big vector notation, and then we're going to apply the transformation, apply the translation. So what's the rule?
Big T.
Big T.
Sideways V.
Arrow.
Arrow, -3. Or, -1, comma, 3, arrow.
Okay, so let's talk about what this means. What does the -1 mean? Left. Left what? Left 1. What does the 3 mean? Up 3. So that's what we're doing. Left 1, up 3 on every single vertex. Uh-oh, my point is inside the triangle. What do I do there? Do I just quit and cry?
No.
Is that okay? Can that happen?
Yes.
It's okay. What about here?
Left 1, up 3. Left 1, up 3.
that cool? What? You good? Alright, you're really quiet today. Is it so easy it's boring, or is it so hard you don't know what's going on?
It's so easy.
Is it really that easy?
Yeah.
No?
It's pie.
Hate it? Love it?
Love it.
More examples? Can I make it worse?
Yes.
Always, you know that. Okay, use the rule to find the vertex of the image. That's a loaded question. It says find the vertex of the image. So in your mind, is the image the new shape or the old shape?
All.
Because there's two words, pre-image and image. Which one comes first, the pre-image or the image? The pre-image comes first, so the image is
The new shape.
the new shape. So I just need to take this rule and translate triangle MNO this way. So we have a 2 and 3. What does the 2 do?
Moves right.
Right 2. What does the negative 3 do?
Down 3.
Down 3. So you go to M, N, and O, and you move them right 2 and down 3. You might have to take your pencil and color over the X and Y axis so you know where you're counting from. I did my very, very, very best to exclude all of the graphs that counted by 2s or 3s on your test. They all counted by 1s. So this shape's going to move 2 to the right and 3 down. 2 to the right and 3 down. 2 to the right and 3 down. How do you feel about that? Good? Ooh. What is that shape?
I don't even know.
Ooh. That's just a quadrilateral. So it says, what is the rule that maps A, B, C, D to A prime, B prime, C prime, D prime? What is the dance move that we perform to get from the new shape or the old shape to the new shape? So you have to look real carefully, zoom in, right? Which one's the new shape? Which one's the old shape?
It is the bottom one.
This is the new shape. This is the old shape. So we have to figure out what dance move did we do to get from the old shape to the new shape. So when you write your rule, what's the first thing you're going to write? Big old T. Then we can build our brackets. We just got to squeeze the numbers in there. How far did we go to get from the old shape to the new shape?
-8.
-8. Are you counting left and right first?
Yes.
I really hope so. I'm going to count from D because I'm special. 1, 2, 3, 4, 5, 6, 7, 8. Does that line up with D?
Yes.
8. So I went 8 to the left, which is
Negative.
-8. Okay, I went 1, 2, 3, 4, 5, 6, 7, 8. Now how far is it down?
-7.
Down 7. So if I apply that rule to what shape?
A, B, C, D.
A, B, C, D. It will move that quadrilateral 8 units to the left and 7 units down. Still good?
Yeah.
This is just extra. Okay. What about if I do this? kind of dance move is that?
Left 3, up 4.
It's multiple translations, isn't it? How many translations am I doing?
3.
3 different translations. So you just start at the point 1, 2, over 1, up 2, and I need to move that point, dance move number 1. What does dance move number 1 do?
Left 3.
Left 3, 1, 2, 3,
Up 4.
up 4. 1, 2, 3, 4. So this would be like a prime. Okay, now what? Now what do I do to that point?
And move it to the right 1.
Right 1,
Down 2. Or
Down
up
2.
2.
up 2.
Yeah, wait.
A double prime. Now what?
Then right 2.
Right 2,
Down 6.
what?
Do that to us.
What? It's confusing because there's no grids there right there. So what if I stack all the dance moves? Let's stack them all. So I have 3 different dance moves. So those are all 3 dance moves. Can I just combine all the dance moves and do one move?
Yes.
So what is negative 3 plus 1?
Then 2.
And then negative 2 plus 2.
0.
So if I combine all the dance moves, I get 0 left and right. Now if I combine all the vertical dance movements, 4 plus 2,
6.
6 minus 6.
0.
So did that point even move?
No.
No. So you can do it on the graph. You can do dance move 1, dance move 2, dance move 3, and find out where the point is. Or you can combine all the dance moves together. You can list the instructions. That kind of makes sense? Mapping backwards. Can you do dance moves backwards?
Yes.
Yeah? You do the cha-cha slide backwards?
Yes.
The Macarena backwards?
Yes.
Let me see it. So, if you do, you have to think about it a little bit, don't you? How do you do the Macarena backwards? You just do the same thing in reverse order, don't you? So, if I know I'm doing a translation, it says if I translate point A, what does the 3 mean?
Over right.
Right 3 and
A down 4.
I get a prime. What is the rule that maps a prime back to A? What if I go backwards?
Left 3 and then up 4.
So the rule would be, what is the opposite of 3?
Negative 3.
Backwards, 3. What's the opposite of down 4?
Positive
4. You just flip the rules. You map it backwards. That kind of makes sense? You go the opposite direction. I think I have one more. That's it. That's all I got. So,